Hello and welcome to another video. Today we have an Strix B550 F gaming on our bench. This is an AM4 board. I do not know what is wrong with it. So this came from a viewer also. The same viewer that had a different board where also the BIOS chip was dead. So this is one of the things that we will need to check later, definitely, that the BIOS chip isn't dead and that there's actually proper data on there. But we're going to be starting with the usual checks that we do for a board. Let me quickly remove this bracket that we have here. And let's now get our multimeter. We go into resistance mode and let's now check for the obvious shorts with 12 volts. CPU not shorted, 12 volts to the face, not shorted. Then we connect a ground up. And now let's check the 24 pin, so 3.3 volts, high resistance, 5 volt VSB, high resistance, 12 volts, high resistance, 5 volts, high resistance, that looks good. So we can also see DDR, looks fine for the resistance. We have VPP right here, 2.5 volts, looks fine. Then this is probably PCH, looks fine. That's basically what I can quickly see. So let's go for voltage on the battery. Voltage on the battery is 3.05 volts. That looks fine. But we're going to be removing the battery for now. And yeah, that means we can plug a CPU into here and see for the passive power consumption. Because we have no major line shorts. So we're going to be starting with the 2200G in here. So I would expect around like 150 milliamps as soon as we turn on this power supply. 650 milliamps. That is a lot of current. Does that happen without the CPU in there as well? No. So it doesn't happen with the CPU in there, but it does happen with the CPU in there. So this might this be an enable for something shorted being on the VPP on the or the 1.8 volts? 650 milliamps. That is so much. That is such high power draw. Let's get the heatsinks then off of here. And what we might want to do with a CPU in here, we will be injecting the 5 VSB so that we get in the same state as we are doing currently. So let's get rid of the heatsinks first. So the heatsinks are off, and what we're going to do now, I will be taking my power supply with 5 volts, and what we want to do, we need one ground connection. I like to use the M.2 posts for that. And on the other connection, we are going to be taking tweezers to inject 5 volts into the 5 VSB. And let's see for the power consumption. It has 1.5 amps, which is quite a lot. And we will need the thermal camera then. So let's get the thermal camera out and then inject the voltage again and see what is happening. So now we have the thermal camera ready. Let's now try to inject the voltage. And there's something getting very, very hot right there. Yeah, extremely hot. And it looks like someone has been trying to solder there already. So something has happened there already. Let's get under the microscope and see what has happened there. It was right next to the battery holder. Let's see where we need to be. Right here. Something has happened. Okay, for some reason, this component gets extremely hot. I think I would want to remove it instantly to see if there's anything being done there. So let's get some leaded solder onto the pads and then we're going to quickly hot air it off. So now it will melt a little bit, the connector, but it should remove fairly quickly, so the damage shouldn't be too bad. There's the component off. Let's now wick the place clean. So now we have a clean area. Let's now get some IPA, and then we can look if there's any reason for why that component even was getting hot there. Okay, so normally I think there's a dual diode in there that should be connecting like the 3 volt of the battery with, what is it, with like the 3 VSB or something, and then giving a 3 volt output. Let's see that we don't have a short on any of these. And yeah, there is a short, 3 ohms. So I'm pretty sure that shouldn't be shorted. That is an output. Let's go onto the board view and see for what is that component responsible for. So this is a double diode, pretty sure. Yeah, B550 CW. This takes the battery voltage that comes out of here into there through that 1k ohm resistor, goes into there, and on the other side we have the 3 volt VSB, and then these connect into this 3 volt battery as an output. And this is shorted, which is a bad sign, because it's either this that is shorted or it's the SIO on that line, and I'm fairly sure it's going to be the SIO on that line. So theoretically there should be 3 volt on that part. So let's inject 3 volts into there and see what is getting hot. So, having the thermal camera out again, we now have 3.3 volts, and we're going to be injecting it into that line. And we have 1.7 amps of power consumption. Is it not the SIO that is getting hot? Really? Interesting. So, there's the only other thing is down there, I believe. I have 1.7 amps of power. Oh, right there. Something interesting. I've never seen it this much before. You can see the trace that is getting hot to some place. That is very interesting. Let me zoom down on that. I've never seen it this much before as it is on this one. And it leads us to the place which is behind the coolers. That is really cool. I've never seen it like this, where you can see the exact trace where it's going. So okay, we have to take off the cooler of the VRM in order to see where those 3.3 volts go. So let me do that. So let's see now. Now everything's off. Let's get the thermal camera in here and get the 3.3 volts again via the tweezers. And let's now see who our culprit is. So let's see. It goes into the board here. Interesting. So now you can see the full trace getting hot. And it will be something on the back side then, probably. Let's get my phone out of the way. Let me quickly have a look what there could be if I find anything else. Oh, it goes into the CPU. Interesting. If you can see that on the top left. And I saw something on the backside of the board when taking off the cooler that was a little bit concerning. There seemed to have been work being done right behind the CPU. Let me show you that. We will need to go under the microscope to see what has happened to those capacitors on the back. And have a look there. There's a capacitor that has been moved to the side and another one there probably. And some of them might be responsible for our short circuits. So we will definitely have to remove them. And most probably we can remove them and just leave them off, because they most likely are just filtering capacitors. So we're going to be removing this one and the other one that looks odd, which is this one right here. So now let's get the hot air into here. And let's hot air them off. So both capacitors are removed. Let's get rid of the excess solder that is on here. So we're going to put some flux onto there. And let's clean this place up. And now let's get rid of that blob of solder right here. Like that. And now we should be fine here. So let's now then see again for the resistance if that has changed at all. So let's see now. Our resistance has not changed. Oh, you cannot see that. Now you can see 3 ohms. Okay, so we will have to input voltage again and see what it is that is still shorted. So interestingly, when I remove the CPU, the short isn't there anymore. So question is, where does this short through? We'll have to look at the SIO area. What is happening here? Why we have heat up there? Because this is something isn't adding up here. It seems like someone has really been setting something up here. Something just isn't adding up here. Why 3.3 volts of the battery can reach to there? And I can see some physical damage. If you look at this resistor right here, its top side here is damaged a little bit. That resistor looks really weird. And we definitely have some physical damage here. So question is, which trace is that the 3 volts from the battery is reaching that? Let's go into the board view. I need to see for that what that could be, because it's really weird. I've never seen anything like that. So let's see here. Where do we go? We go to a 2 meg ohm resistor. Does this reach? No, this does not reach. Because this might go. Does this go into the... I'm searching for something that is connected to the 3 volts battery that could be going straight to the CPU or close to the CPU. Super IO, LDO, this is also just a regulator. And there's the Schottky. So let's see if this 2 meg ohm resistor is actually 2 meg ohm resistor, because I think that's the one that someone has been tinkering with. So let's see here. We want to see 2 mega ohms of resistance. So really high resistance. When we check that resistor. And that is 0. What? That is supposed to be a 2 mega ohm resistor. So this is the line. Let's check. This is the line that is connecting to the 3 volt battery. Yeah. Has someone put a wrong resistor into there? Because a resistor cannot go short circuit. A resistor can only go open circuit, but not short circuit. So let's put that to the side. It has leaded solder on there, and what we're just going to do, we're going to be blowing it to the side. Just like that. And let's check that again. So let's check if this part is the one from the battery. Yeah, that is what's coming from the battery. And let's now check if that battery still has 0 ohms. Yeah, and now the short circuit of that is gone, because it's... Yeah, that side has low resistance. Because that goes into the CPU. That's exactly the CPU that we're measuring here. And this resistor right here is supposed to have 2 mega ohms. And this is a 0 ohm resistor. So someone has put a wrong resistor into there. Someone has put a 0 ohm instead of a 2 mega ohm resistor into there. Which is completely wrong. Like, how? Like, I hate faults like that, because these are man-made faults. They make no sense. And someone has been tinkering with that, and I wasn't told that this was tinkered with. And this makes my job a lot harder, because I don't think that this is the original fault. There's probably something else faulty here, and we will have to figure that out after having removed that and now putting a 2 mega ohm resistor into there. So let's see. Let's get a 2 mega ohm resistor. So I do not have a 2 mega ohm resistor. So what we are going to do, we're going to be taking two 1 mega ohm resistors and going to be putting them in series in order to get 2 mega ohms here. So these resistors aren't quite a mega ohm, they are 910k ohms, but that will be fine. So my plan here, we're going to be connecting them in series. Each one is going to be soldered on by one pad, like that. Let's get Flux onto here. Now we will take the other resistor, and we're going to be connecting the other resistor to the lower pad right there. So they are both connected to the pads now, and what we're now going to do, we are now going to be solder bridging them together on the other end, just like that. And now we have a 2 mega ohm resistor. So let's clean up the flux. So now we have a beautiful botch job of two 1 mega ohm resistors in there. And let's now get Multimeter into here again, and let's see if we get almost 2 mega ohms of resistance for those two pads. So we're going to be checking from there to here. And it's charging up. So we're getting higher and higher ohms. But we can already see 1.5 mega ohms, so that is definitely fine what we need here. Because this really doesn't need to be exactly 2 mega ohms. It will be draining the battery a little bit faster with lower readings, but it should be fine. Question now is, are we supposed to have that low of a resistance reading on the other side of those resistors? Like, we can see directly the reading of the CPU there. And the question is that supposed to be that case? So if we go into a low ohms range, we see on this side of the resistors right there, we can see 2 ohms. And if I'm taking the CPU out, what I'm doing right now, you can see it goes high resistance, and closing the latch, it goes low resistance. So let's check how this could be connected to the CPU. So let's see. This side, this has a connection to the Super I/O. It is connected here to an N-channel MOSFET, but this is the gate of that N-channel MOSFET, so I don't think that could be anything. Just like this is an N-channel MOSFET, except if one of those MOSFETs is maybe shorted, we might see that. Oh no, this isn't. Wait, this MOSFET, yeah. If this MOSFET or this MOSFET is shorted, only then I could see a path directly to the CPU. Because everything else not connected, not connected. Not connected, not connected. Everything here. And only SIO and N-channel MOSFETs. Okay, so let's see then. Let's check those MOSFETs for short circuits. So let's see, the gate isn't shorted. The gate is connected to source here though. That is weird though. So this is connected to here. But this is the CPU resistance, I think, right? That we see here, because this is to ground. Yeah, this is to ground. Yeah, and with no CPU in, we do not have a short here. But when we're putting a CPU in, we get a short. Okay, so this is just reading because this is going to the CPU, but not from here. Okay, then let's see the other one, which is somewhere here in this area, which is exactly this transistor. And again, it's the gate, And we're probably again going to be seeing a connection to the right pin. And now taking the CPU out. No connection to there. And no connection to there. I do not know where this connection is coming from. That there's actually a connection to the CPU here. Well, let's just see how this board reacts when we build this up now, because the main short that was on the 3VSB isn't there anymore. Let's see if something may blow up here or not. Because I really don't know how that resistance of the CPU gets to that place. Maybe it should be there, but yeah, I do not know how that is connected to each other. So, first thing that we want to see is that the passive power consumption now is low. Before we had like 600 milliamps, and that shouldn't be the case anymore now. So let's see then. Turning on the passive power consumption. 110 milliamps, like we would expect. Okay, let's press the power button. And we have no reaction to the power button currently. Interesting. I want to know what voltage is on that line where those 2 mega ohm resistors are. So we do not have any voltage there. Oh, I forgot. Yeah, of course. I forgot to put the double diode back in there. Yeah, right. It cannot have worked because the double diode isn't reaching there. I'm not too sure if that double diode is still fine or not. I will just replace it because I have those in stock. So let me get a new one and we will be soldering it in next to the battery then. So getting some flux into here. So, and now let's get that one tab on first. And now we're going to be connecting the other two. So let's connect that pin and this pin. And now our dual diode is in there. Let's now clean the space up and then try again. So, moment of truth. Let's now see again if we now get a reaction. And still no reaction to the power button. Let's see if those voltages are present that we would expect. So we need 3 volts here, 3 volts there. Now we need 3 volts here. 3 volts there. We need 3 volts at the output of those two resistors that we soldered. And there's nothing there. I don't know if there should be 3.3 volts on there or not. Let's see if we have even the 3.3 volts on the... Yeah, we do have the 3.3 volts on the power button. So there could be basically anything wrong now here with this board. I would want to know what happens when we short PS on by ourselves here. Almost nothing. So almost nothing is starting up. If you see 250 milliamps like that when shorting PS on, there's some major rails missing here. So we need to see if the 3VSB is now running. And it is running. Let's check. The 5-volt dual should also be then running. We need to check if the voltage... Yeah, for example, this here. This seems like the voltage for the PCH, and this has 0.5 volts. This is not correct. So there's something wrong with that also. So we will need to check that, and we have to find out where VDDP is being created. I think it's being here on this chip. Yeah, and I think this chip also has not VDDP where it's supposed to have VDDP. So let's go into the microscope and check for those areas. So first area that we saw had problems is this one. This area has... Oh. What? Someone has cut this ferrite bead. I'm being set up badly here. What the heck is happening here? Someone has cut off this ferrite bead here that is supplying voltage. Man, what is this board? There's so much wrong with this. Let's see if I can reconnect this. So I think it's reconnected now. Let's see, connecting one side. To test it, I will be connecting to this side with one probe and to the pad of the other side, and we should get basically 0. Yeah. Okay, another thing fixed. Let's see how the board now behaves. So let's see now. Reaction to the power button. Still nothing. Oh. How many faults can this one board have? Like, what else has been tinkered with this on this board? Let's see now for voltages. For that ferrite bead, I would be interested. Is my 150 milliamps. And now we have a reaction to the power button. What is happening on this board? CPU, VGA, 4 amps. Help. Okay, something very weird is still with that ferrite bead. I think my connection isn't quite as it should be. Yeah, it's not connected yet. Okay. The solder connection that I tried to that ferrite bead wasn't great. That's why that sparked. Let me do that again. I will just, this time, I will be taking a wire to connect that ferrite bead properly to its pad. So to see under the microscope, I just used enameled wire and connected it to the ferrite bead right there and there. That we have a connection here. Because I wasn't able to connect it there anymore. So this is connected now. Let's go into the overview. So, and it seems to be that the board can now boot. So let's see now. Having voltage in here, 150 milliamps, and pushing the power button, and now we have actual boot up procedure. VGA, and we should get a BIOS screen, splash screen any second now. Let's see. Is this on already? Because we have a green boot, but I do not get any video output. Yeah, but the indicator for the indication is working for the keyboard, so the board has already turned on. I just do not get a video output currently. Oh, I do. I just had something with my OBS wasn't configured correctly. So yeah, the board is on. Let's see, let's get into the actual BIOS. So there we have an actual BIOS screen and the board is now working. So let me build everything properly up, get all of the coolers back onto here, and then have this board once more working. The big question now is, what was the original fault with this board? Like, what happened here? Because this was just a mess of faults on this board. Like, they didn't make any sense at all what was wrong here. None of these faults seemed like there were faults that happened by themselves, like an actual electrical fault. So what did we have of faults? We had a wrong resistor, a 0 ohm instead of a 2 mega ohm. That doesn't happen at the factory. That has to be someone putting the wrong resistor in there. There's no other way that can happen. And after that, there was the cut leg of the ferrite bead. Like, why would anyone cut that leg of that ferrite bead? Like, there's no reason to do that. And after that, there's also the capacitors that we saw on the backside that were broken. Like, that had that were definitely out of place. Like, I do not know what was wrong with this board. Like, sure, we fixed some things, but what's the history on this? I just cannot make out a scenario where I would say, yeah, this is what happened to this board. Because these are not faults that happen naturally, as far as we can obviously tell. So, yeah, very, very weird. Because I expected, after having fixed those man-made faults, I would have expected that there's a fault that is like actually traceable to faulty electronics. So now the board is fully built up again. And let's now hit the power button, see that we get into Windows and be done with this board. Like, I'm beyond confused what has happened to this board. Like, there was some weird tinkering done with this one. There's the BIOS screen. Let's get this into Windows. I've never seen a short on the 3-volt battery before, because there's no real short. There wasn't really a short there. There was just a wrong resistor in place. That was why that was shorted. And the previous technician definitely saw that there was a short with that, because he was doing soldering on those diodes. On that dual diode that was getting that hot. And there was definitely also soldering done with that 0 ohm resistor. Like, and then there's the farad bead that was snapped off cleanly. If you have any idea what could have happened here, let me know, because I have nothing to say on this one. Like, I'm happy that it's fixed, but these faults make no sense. Like, wrapping your head around these is just so weird, with faults that are not natural. But yeah, the board is now working. This is a great board to have. And yeah, what can I say? I hope you learned something in this very weird video. I hope you enjoyed it. All of my tools, as always, are linked in the video description. This was Mainboard Medic. Thank you very much, and goodbye.